Okay, in the next section 4.3 we're going to look at a couple of models where there is trend present as well, as well as the seasonal component. So when we have trend also, one of the things that we need to do first is to remove the seasonal variations, so you'll have only trend present in the data set. So you have to strip the seasonality out of the data set, and then we can fit a trend, and then we can add the seasonality later on. So if it is an additive model, the including of the seasonality will be adding a seasonal component. If it is a multiplicative model, then it will be multiplying the trend forecast with a seasonality factor. Okay, so how do you strip the data of seasonality? And for that, we have to first come up with what is called seasonal index for each season. So if you have 4 quarters, we need one seasonal index for each of the 4 quarters. If you have 12 seasons, monthly season, then we need 12 seasonal indices for each of the 12 months. So we have to come up with a seasonal index. And once we have the seasonal index, then we can use that to strip this seasonality out of the original data. If it is an additive model that we are assuming, then we subtract the seasonal index value from each of the actual values. If it is a multiplicative model, then we divide. So the difference between additive and multiplicative model is wherever we add, we multiply in the multiplicative model. Okay. Wherever we subtract, okay, we divide in the multiplicative model, or vice versa. So if you multiply here, then you add in the additive model. If you divide in the multiplicative model, you subtract in the additive model. So you have to keep that in mind. So one approach for developing the seasonal index is what is called just straight averaging. That is, you take the average of one complete season and then compute the averages down the line as a moving average. Okay, so like average, if you have a 4-period data set, you find the average starting from the 5th period for one full cycle. So before 5th period, you will not have one full cycle. So you have to go down one full cycle and then start averaging. And then if you then come up with seasonal index. We'll look at how to do that in just a second. Then you detrend. So detrend value of y superscript dt is detrend for a given time period is y sub t minus the trend component that we're going to develop. Okay, and then we will proceed through the rest of the steps. Let's look at these two first. Let's go to the Excel file. So we'll get to these in a little bit. Okay, this is the additive model that we are going to assume here. And as I said, multiplicative is just the same, except that wherever you add, you multiply. Wherever you subtract, you divide. Okay. So first step is to deseasonalizing the data. Okay. Okay. So that's what we're going to get here. First thing to do is to find the average. So since this is quarterly, we're going to do one full 4-season moving average. If it is a monthly time series, then you have to leave first 12 months, start from the 13th period or the first season of the second cycle. And the reason why we have a line here is we're going to fit an LES model later on. So that's the reason why I have a line there. So this is average of the first 4 seasons. Okay. Now you copy that all the way down. Then you have one average of the immediate past 4 seasons. So this will be like all the seasonality removed. So this moving average is all the seasonalities removed because you're averaging one entire cycle of seasons. Okay. Now these moving averages are the values of the time series where all the seasonal effects have been averaged out. So this only has trend in it in a sense. So when we take the actual value and we subtract that average value out of it, then what remains is only the seasonality. In other words, we have taken out the trend part. So that's why this is called detrended series. Okay, so this is the detrended value for quarter one of year 2. Okay, so same. Copy that. So the moving average gives us values where the seasonalities have been averaged out, so it only trend remains, and if you take that trend out of the actual value, then only the seasonality remains. Remember, we are subtracting because this is an additive model. If it is a multiplicative model, subtracting should be replaced with division. So now we can assemble these detrended. Only is the seasonal factors, the additive factors here, and there is no additive factor for year 1, so that will be blank. So year 2 quarter 1, okay, I'm sorry, year 2 quarter 1, year 3 quarter 1, and year 4 quarter 1. Okay. Now if we copy these, then we have each of the years arranged by quarter 1, 2, 3, and 4. So quarter 1 seasonal effects from year 2, 3, and 4, quarter 2 seasonal effects, quarter 3 seasonal effects. So if we average them, that gives you the average of the seasonal additive seasonal effect for quarter 1, the average of the additive seasonal effect for quarter 2, quarter 3, and quarter 4. Okay. Now when you average these, okay, some of the quarters will have positive effect, some of the quarters will have negative effect, so the average must be equal to 0, but usually it will not be. Okay. And therefore we have to what is called standardize the seasonal means, and that's called the adjusted seasonal mean, and those are the seasonal index values. And the way we do that is to subtract these seasonal, the overall mean from each of the seasonal means. Okay, if it was a multiplicative model, so instead of subtracting we would be dividing. So we take the seasonal mean, subtract that mean. We need to make that absolute reference so we can copy. So that is the adjusted seasonal index. Now if you copy the mean of these means, you'd see that this will be 0 because we've adjusted the seasonal index such that the positive effects, the negative effects all average out to be 0.